In quadratic functions, we're looking at those graphs and looking at even more clues about a quadratic. Specifically today, we are seeing the maximum, the minimum, which we did look at in the previous lesson, the vertex, the axis of symmetry, the y-intercept, the domain, the range. We're looking at all those aspects, and we're really zeroing in on the axis of symmetry and how to get the equation for it. So the vertex, like we saw yesterday, is the point where it either bounces back up, or if it were a maximum, where it hits its peak and then starts to come back down. So the vertex can either be a maximum or a minimum point on the graph of the parabola. Now where the vertex bounces back up, that's going to be called the axis of symmetry. We usually show that with a dotted line. It's an imaginary line on a graph where the graph is a reflection of itself. If I were to fold that parabola in half, it would be a mirror image of it. The roots are going to be very important in lessons to come. That's what's pointed in green right here. These are the locations on the graph where the curve touches or crosses the x-axis. Now this is also known as the zeros of the graph. They are extremely important because as we start to solve quadratics, you can use a graph, and those points are the solutions of the quadratic. A lot of information on this slide, so let's take our time here. In the quadratic function of y equals ax squared plus bx plus c, that's that standard form, the value of the b term affects the position of the axis of symmetry. Now let's think about those parabolas that we saw in the previous lesson. They did not have a bx term. Its axis of symmetry was the y-axis. So keep that in mind as we start to see how you find the number value of the axis of symmetry. So let's consider these following graphs here. This first one, its axis of symmetry is on negative 1/2. So x equals negative 1/2. That's that vertical line there that goes through the vertex. The second graph, y equals 2x squared plus 4x, its vertex is crossing through y equals negative 1. This third graph, y equals 2x squared plus 6x, its axis of symmetry is at negative 1/2 or negative 3/2. Now each of these have the same a term, 2, 2, and 2. They do not have a c term. What is different about each of these is where the axis of symmetry lies and the b term right here, the 2, the 4, the 6. The larger that number was, the farther it was shifted to the left. Notice the axis of symmetry changes with each change in the b value. The equation for the axis of symmetry is related to the ratio of b over a. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. So we can kind of see where these are fitting in here, but that doesn't get us exactly the axis of symmetry. Oops, me. Okay, this first one here. The equation is y equals 2x plus 2. So the a term and the b term are both 2. So those divided out are 1. The axis of symmetry is negative 1/2. So how is it that 1 can move in to be negative 1/2? Try to think about that. Let's go to the second one. 4 over 2, the b term over the a term is 2. But somehow 2 ends up becoming negative 1. The third one, 6 divided by 2 is 3, but 3 leads us to the axis of symmetry of negative 3/2. How each of those are changing is you are multiplying b over a by negative 1/2. Or you can kind of put this together instead of having multiplying the two fractions, as you take the negative b term and you divide it by 2 over a. So here is the main idea. The equation for axis of symmetry, you can either think of it this way, x equals negative 1/2 times b over a, or x equals negative b over 2a. So let's take a quadratic. I'm just going to make one up here. Y equals 3x squared minus 4x plus 1. So if I wanted to find the axis of symmetry, that line is going to be equal to x equals negative, the b is negative 4, over 2 times a, which is 3. So simplify this down. That would be 4 over 6, and it's negative times a negative, which will be a positive 4 over 6, which would simplify down to 2/3. So x equals 2/3 would be the axis of symmetry. So if this were our graph, our axis of symmetry is going to fall a little bit over here on the positives, about right here. That's where my parabola would be reflected. I can tell it's going to be positive because it has a positive, it's going to be pointing up. It's going to be very skinny because it's 3x, and it's up 1 because it is a positive 1. So our graph would look something like that. Just a very rough sketch. So graphing a quadratic using the axis of symmetry and the vertex. So step 1 is to find the axis of symmetry. So we have that formula. It is x equals negative b over 2a. So let's plug in our values. The b value is negative 6, so that'd be negative 6 over 2 times a, which is 2. So the negative times the negative is going to give a positive 6 over 4, which would simplify to 3 over 2. So our axis of symmetry is x equals 3 over 2. And that's the same thing as 1.5. Step 2 is to find the vertex. The x-coordinate of the vertex is the axis of symmetry. So what you do is you substitute that into the equation for x to find the y-coordinate. So here's our equation. I'm going to substitute 3 over 2 because it's crossing like right here. There we go. So I'm going to substitute that in for x. So 2 times 3 over 2 squared minus 6 times 3 over 2 plus 1. Okay, so when I square 3 over 2, I'm going to get 6 over 4. No, I wouldn't. I'm sorry. I'm going to get 9 over 4. Okay. So then 2 times 9 would be 18. 18 over 4 would simplify down to 9 over 2. I'm struggling with my 2's today. Minus 6 times 3 is 18. 18 divided by 2 is 9 plus 1. So I'm going to think of 9 over 2 as 4.5. So 4.5 minus 9 is going to be negative 4.5. And then negative 4.5 plus 1 is going to give me negative 3.5. So that means the y value for the vertex is negative 3.5. So as a coordinate, that's going to be 1.5. I'm just going to put them all in decimals, 3/2, which should be 1.5. And the y value is negative. It's not wanting to write. Oh, there it goes. Negative 3.5. So let's graph that. Positive 1.5 down 1, 2, 3.5. So right there is the vertex. I'm going to go ahead and put a dotted line here. That's not part of the graph, that's just showing the axis of symmetry. So now I need to find 2 other points, and then we can reflect it across it. Find the y-intercept by substituting 0 for x, and so that will be the easiest one to substitute. So 2 times 0 squared minus 6 times 0 plus 1. 0 squared is 0. 0 times 2 is 0. Okay. 0 minus 6 times 0 is 0, and then plus 1, which is going to be 1. So when x equals 0, y equals 1. 0, 1. Then I'm going to graph my point. Oh, I need to do another point. I'm sorry. Let's do the x-intercept and see. Well, that wouldn't work. That wouldn't be very good. Let's put let's put positive 2 in there. Let's see what we get when we do that. I'm going to do that in a different color over here. So 2 times 2 squared minus 6 times 2 plus 1. So 2 times 2 squared is 4, 4 times 2 is 8, minus 6 times 2, which is 12, plus 1. 8 minus 12 is negative 4. Negative 4 plus 1 is negative 3. So that coordinate would be 2, negative 3. Positive 2, 1, 2, down 3. 1, 2, 3. So there I have another point. So graph my points. Notice that each of my points were on the opposite sides of the axis of symmetry. So I've graphed the vertex, I've graphed the 2 points, and then I'm going to reflect those points. So there's going to be a perfect reflection right here, and there's also going to be a perfect reflection right there. And so based on that, I can get a general shape of my parabola. In class, we're going to be working with the graphing calculators, which are going to be much more beautiful than what I just did on the screen right there. We'll get some more practice with it. It won't be quite as tedious because you'll have the calculator to do those things for you. So look forward to that in class.